Okay, hello. So this is the second lecture for network service and services, and I will explain Kickstart and everything that we need to know about it in order to complete it in the lab. So Kickstart is a method to do unattended installations in CentOS, in Red Hat Enterprise Linux in general. So what we'll do is we will have a host which will be our deployment server, and we will need to build one or more, depending on how far you reach in the lab sheet, clients from it. The idea is that you build the clients automatically without any user input or with minimum user input in the beginning. So for example, we use Kickstart a lot here. All of the computers in this lab and all of the computers in 822 and 823 as well are built through Cedric's Kickstart server. Okay, so if one of these computers has a problem like hard drive fault or something like that, all we need to do is start it up, boot from DHCP server, and then select the correct Kickstart installation, and then just builds completely on its own. So the target is, our aim is to show you exactly how to configure this as a service so that you know how to actually do it in the future if you ever need to do something like that. So all of the documentation about it is on the Red Hat manual pages, which are very good in this particular aspect. And we need to talk about the system that we'll use. So we need the virtual machine for the installation, and the easiest way to do this is VMware, because obviously we don't want to do this between physical hosts, because we don't want to mess around with the computers in the university. You will have your Prometheus VM, which will be your deployment server, and inside it you'll have a VMware installation, and in there you'll be able to start your kick-started client inside VMware itself. So you will need to create, for starters, you have your Prometheus created from last week, so you need to create a blank CentOS 7 virtual machine. For this, you don't need a lot of resources, so you can give it 20 gigabytes of hard drive space and a couple of gigabytes of RAM and a network interface. The network interface can be made on a host-only mode. All right, so I used to do this in a custom mode in the past. I've now set it up so that it can be done on host only as well. It doesn't really matter. The only thing that matters is that you have an as direct as possible connection between your host and your virtual machine. For all I care, you can set it up as a bridge as well. It really doesn't matter to me. Okay, you can't use nothing because of the way that they communicate with each other, because of the way that the virtual machine is knotted on the host. All right, so you can choose to use whatever method you like. It's fine with me. All right, and we'll help you accordingly with it. So in order for all of this business to work, we need to have certain services in place. The first and most important service that needs to be here is our DHCP server. So we need to have a DHCP server configured on our Kickstart server that will basically tell our clients which IP address to get and actually where the Kickstart configuration file is located as well. So if we go back onto Moodle and we go in the Kickstart utils folder, you'll find that there is a dhcpd.conf file. So this is the file that we need to edit. So I've downloaded this already. So let me go find it. I downloaded it in the wrong module. That's great. Where is it? Brilliant. It's okay. So this is going to be your first nightmare, configuring the dhcpd.conf. So the idea is that we give this configuration file all of the information that is needed for the client to start from it and start the installation. Now, what sort of information do we need on a dhcpd.conf file? So any configuration file needs to know the server identifier. So it needs to know who the DHCP server actually is. All right. In our case, your DHCP server is going to be your Prometheus VM. So the IP address on this will be 148.197.28. Whatever the IP address of your Prometheus is, which it should be whatever your host IP address is, so whatever is on your monitor plus 50. Okay, if you don't have it like that, you need to configure it correctly before you do anything else. So once you have the IP address of the host there, we go down to the subnet declarations. So the DHCPD.conf file needs to know about all of the active network connections that you have on your server where it's working. And then it needs to know on which of these connections it's actually giving out any information, in which of these connections it's serving DHCPD requests. So in our case, we have subnet 148.197.20.80 with a default class C subnet mask. So this paragraph should be the same for all of you because you're all connected on the physical sort of network card of Prometheus going out onto subnet 28. Okay, now from there on it will depend on what you actually decide to do with how you will set up the networking on your Prometheus VMs. All you need to do is type ifconfig and then any network card that pops up except for the loopback, you'll need to create a statement for it in your DHCPD.conf. Okay, so if you do go with custom networking and you create a VMnet 0 and a VMnet 1 network card for future use, you can configure your VMnet 1 IP addresses, which will be on subnet 31, on this blank subnet declaration. The easiest thing to do, like if you're using host only, for example, or if you're using bridge, you don't need to have any other paragraph really. Okay. So, the subnet declarations for the blank network cards that will not be used in your DHCPD deployment. They only need to have the subnet line and you need to close the bracket in the end of it as well, because at the end of the day it's a script. Once you have the blank subnet declarations, we then move on to the subnet declarations that matter. So this will be the subnet in which your DHCP client will live. Alright. So your virtual machine will be built on this subnet. In this particular example, the DHCPD.conf is built for a custom configuration. So this is with running the VM subnet script and creating a network on subnet 30. So we have 148, 197, 30 dot whatever the network address is going to be on that one, with whatever subnet mask it's going to have after it as well. If you want to do it this way, then you'll need to be careful. And if you are using these range of addresses, so subnet 30 for example, the IP address range that you're using here needs to abide by the rules of the a2.net subnets PDF file. So this guy is this one. Okay, so depending on which computer you're working on, the range of usable IP addresses that you can have are defined in this particular table. Alright, so if you do decide to go with those addresses, then you can do it like this. Now, once you have your network and subnet mask here, you need to have your option routers statement. So this is the IP address of the default gateway of that subnet to the outside world. By definition, this will be the IP address of whatever network card you're running on your Prometheus that connects you to the virtual machine. So if it's host only, for example, then you need to look at your VMnet 1 IP address on your ifconfig on Prometheus, and that will be the IP address of your gateway. If you're running a custom script, for example, with VM subnet, then that will be whatever you've named your VMnet network card and its corresponding IP address here. So this address is essentially the gateway for your client to the outside world, which of course happens to be on the machine itself, on Prometheus itself. So that's the option routers, is the gateway. Subnet mask will be the same as whatever you have here. Broadcast address will be whatever the broadcast address is for the network that you're using. And then log servers, you can just set it up to the address of Prometheus itself, and Prometheus will do the logging for your DHCP server. Other than that, you need the next server statement, so you need to set that in exactly the same IP address as up here, so that the system pretty much knows that there is no other DHCP server to ask. This is the only one with any authority in the network. And then from there on, we'll go on to the host declarations. So this is the area where we will define our client, the virtual machine that will be built via Kickstart. So what we need to know, make sure that, these are commented out. So these are comments. So anything behind here is simply a comment after the hashtag. What you need to have is the host name here. So v, whatever your computer is you're working on, 0. You can have it v Prometheus 0 or whatever you like. The important bit to change is this, the hardware Ethernet. So this will be the MAC address of the network card of your client. So by this point, you should have built the blank virtual machine in VMware that will act as your client. Okay, so this needs to be the MAC address of the network card in there. It should start with 000C29 because that belongs to VMware. So the only other elements that change are the last 3 parts. Ways to find this MAC address: boot up the virtual machine without a DVD image connected to it. It will try to start from the network, so it will give you its MAC address. Or go to the settings of the virtual machine, go to the network card and go to advanced and see if there is a MAC address in there. For this to work, you need to boot up the virtual machine once, because that MAC address gets generated the first time you boot up the virtual machine in VMware. Okay, even without an operating system inside it, we're just talking hardware side of things now. So that MAC address is the MAC address of the virtual machine. The fixed address is the IP address of the virtual machine that you're building, your client. So it's the IP address that you want your client to receive from the DHCP server. So if you're using host-only networking, it will be whatever you have on your host IP address, on your host's host-only network card, +1, or if you're using the custom script that we have, then that will essentially be the second usable IP address here, and so on. And then in the end, the last line for this DHCP server is this statement, which basically tells the client that, look, yes, it's you, I recognize you, this is your MAC address and I know it. Here's the IP address that you need to get. Oh, and by the way, I have a Kickstart configuration file for you, and it's located in user kick KSCFG. Find that file and follow the instructions for your installation from that file. So then the system will automatically start the installation, and it will try to find this file. This file, the Kickstart config file, will be located in one of the directories of the server. All right, so it will be located actually in user kick KSCFG. So now your newly built client that has received an IP address and is blank and is on the network is trying to find this particular file on the network. This means that you need to share this file in the local network. So you need to start a service on your Prometheus that does network file sharing that will share resources to the internet. So you need to configure NFS. In order to configure NFS, you need to configure a file for it, and that file is called exports file, and it's one of the most difficult configuration files. It's not. It's pretty much 2 lines. So I will make it even easier. We can get rid of this one and this one. So your KSCFG file is located in user kick. So you want to share the directory user kick onto, let's say, network 30. Whatever your network address may be here. All right. So let's say 30.0 with whatever corresponding subnet mask you have for this particular network. So if you're sitting on Farina, which is the first computer here, then this is what your file should actually look like. You should be sharing your Kickstart config file to your network. So any computer that's connected in your network should be able to get this. Do not share this, so do not configure NFS for the entire subnet. Okay, because if later on there is routing in place and everybody can see everybody else's subnet 30, then you might get conflicts. All right, so if you are going to share something on network 30 or any other network you use, make sure it's a network that only exists on your computer. So we're sharing user kick with this line, and then with the other line, we're sharing mount deploy. Mount deploy is simply the location of where we will copy all of the contents of the CentOS DVD. So we'll have the CentOS DVD, or rather the ISO image of it, and we need to take all of the contents of that image and extract them from the image and paste them into mount deploy. Because once Anaconda, the installator, the installation software from CentOS reads the KS config file, it will follow the installation steps because the Kickstart config file is an answer file to the installation, and it will go looking for the source files. It will go look for the installation media. The installation media should be copied onto mount deploy. Once the system has all the information that it needs from the Kickstart config file, what sort of language to install, what sort of packet selection, software selection, what sort of partitioning to create, and so on, it will go into mount deploy, copy all the files in the system, and start the installation. So that's job done with your exports file as well. And then we need to essentially look at your config Kickstart file, and I will show you what it looks like as an example, but I don't want you to edit this particular file. This file is best created using the system config Kickstart configurator. All right, so CentOS has a utility, a nice GUI that you open up, and you use it in order to create this file. So it gives you a listing with different tabs for all of the sections, one by one, of all of the information that this file needs to contain. So there's a section for hard drive partitioning, there's a section for software, and everything else. So you fill in the information there, and then from there you go File, Save, and you create a Kickstart config file, you save it into user kick, and it's done. Information that you need to have in there is, for example, installation media. So this statement here will basically tell Anaconda that, look, the installation files are actually in mount deploy on that particular IP address. And you can reach that IP address because we have NFS in place and it's working, so you can go and get the files from there. Do a graphical installation during the setup, switch off SE Linux, disable the firewall, set the keyboard layout to UK or whatever it is, load the bootloader, and the location of that bootloader will be in the master boot record. Networking information, so this is where you'll say, okay, so I want to have one network card on my client, and that one network card needs to be configured with that particular IP address, that gateway, that subnet mask, and so on. And this information will be exactly the same as it is in your client section in your dhcpd.conf. And you also have hard disk partitioning information, for example, clear partitions, and everything else, and so on. So, and most importantly, in the end, you need to have the software selection. So you need to decide what the installation that you're creating, what do you want it to look like. All right, you can just create a normal workstation. You don't need to have anything too fancy or too much in it. So you can just go into the list and select all of the components and apply. Make sure at the very least you have a graphical user environment. You have StartX, okay, and one of the window managers like GNOME or KDE or XFC or whatever else is offered to you in the installation. All right, I would like the VM that you built to have a graphical user interface, because then if the VM that you build is good enough, you can use it for the second lab sheet, as the client for the second lab sheet, which is LDAP. Okay. And yes, you could do the LDAP lab sheet on a terminal only or run level 3 VM, but then you wouldn't be able to do the last bonus part of it, which is login graphically. So yes, okay. So this is the Kickstart config file. Now, the way that it works is this. You start up your client virtual machine. You set it to boot from the DVD, but before it boots from the DVD, or before rather you do you let it do the installation, you interrupt the startup sequence, and you type this. Okay, so you're telling the system that you need to do a Kickstart installation, and the location for the Kickstart config file is in that place. Okay, so same as you're declaring it on the DHCP server, it needs to be mentioned in to the command that you're building in the beginning when it starts the installation. So when you press enter, the system will look for a DHCP server. It will get the IP address and the location of this file as well. It will go to find the Kickstart config file. It will read all of the information on the Kickstart config file. It will then go to man deploy and fetch all the data from the DVD, from the ISO image. And with all of that information, it will start creating the installation. When it's working, you shouldn't need to do anything. Okay, if at any point it asks you for user account or partitioning, or it complains about partitioning or anything else, it means that it's not working. All right, you should, next time you have to give any input to the VM, be to actually log into the system that has been finished and is complete. Okay, there are a few details about it as well, and there is an additional task in the end. So for a truly unattended installation, completely, the one that doesn't need the DVD even in the beginning, you can also do what is called the PXE boot. All right, so this is an additional task, and you can build a second virtual machine for this if you want to. So you can add to your dhcpd.conf file and everything else. So you can build this, and this will be the extra task for this. We will not help you too much with this, because this is for the 70% plus mark. Okay, but we will a little bit. Okay, all right. So start with breaking down the whole process of how it actually works. Read the instructions on the lab sheet about where all the configuration files must live. All right, so for example, the dhcpd.conf needs to be in etc. DHCP, the exports file needs to be in etc. and so on. It is all in the lab sheet. Okay, if you get stuck anywhere, ask us, and make sure that you get all of the components one by one. I will definitely allocate 2 weeks to this. All right, but if you manage to get it working first week, then good. You can spend more time on trying to get the PXE boot for the second week as well. But you have 2 weeks to do this. All right. So 2 weeks for this, and then there's 2 weeks for LDAP. So we have 3 weeks in front of us before the consolidation week. So that's 2 weeks of Kickstart and 1 LDAP, and then we have 1 more week together after the consolidation week for the second part of LDAP, and then you move on to the lectures, to the lab sheets with Linda for whatever she's doing. Okay? Any questions about this? Yes? All right, we'll fix that. Okay, thank you.